What's going on, everybody? It is Kistner again, and today we are looking at 4.3, multiplying and dividing rational functions. So one thing we need to remember is we're just multiplying and dividing. There's no fancy new technique of multiplying and dividing. That's the same thing we've been doing with normal numbers, but now we're using these rational functions that we've been studying, where it's a function over a polynomial over top of a polynomial. So let's get into this. The first thing you're going to see on your screen here, by the way, in your student companion, you should be on page 97. Page 97. This is just the concept that we're going to cover to start. This is not in your student companion. This is just something I want you to read. It says a rational expression is the quotient of two polynomials. The domain is all real numbers except those for which the denominator is equal to 0. So x squared over x squared minus 9 is an example of a rational expression. But since the denominator cannot equal 0, that means that whatever is in our denominator cannot equal 0. So it's x squared minus 9, that can't be 0. So you factor that, you add the 9, take the square root of both sides, x cannot be 3 or negative 3. So the domain of all of this function, expression, x squared over x squared minus 9 is all real numbers except 3 and negative 3, because that's what makes our denominator 0. If your denominator is 0, it's not that whatever does that cannot be in your domain. You just say it's not part of your domain. So it'll be like this bottom sentence. Now, let's try this. Write an expression equivalent to this weird function, expression, and remember to give the domain. So I'm going to rewrite this so I can mess around with it. So 3x to the 5th minus 18x to the 4th minus 21x cubed, that is in standard form, 543. And then 2x to the 6th minus 98x to the 4th. Okay, so the first thing that I notice here is that everything that I wrote down had an x in it. So I can factor out an x, but we're going to treat it like a top and bottom. I'm going to treat it as two separate problems for a little bit. Up here, I notice that every coefficient is divisible by 3. So I'm gonna write down a 3. Actually, let me change the colors up here. I'm gonna write down the 3, and every single one of them has an x to the 3rd in it. You remember, you factor out the highest exponent, so x to the 3rd. Now, what's left over is 3x cubed times what gives me 3x to the 5th. That's going to be x squared minus 6x. 3 times negative 6 is negative 18. Cubed times 1 is 4th. Minus 7. That's what I have left from my original. I factored out 3x cubed. That's what I have left from my original. You have to know how to do that, or this section is going to be very long for you. On the bottom, what can I factor out? I can factor out a 2, both of them are even, and an x to the 4th. And what's left is an x squared minus 98 divided by 2 is 49, and that's what I have left. Now, before I start canceling anything out, there are some things that I can cancel out right now. But before I start doing any of that, I'm going to keep factoring because I believe both of these can be factored again. So I have 3x cubed, and this thing can be factored. This top one can be factored into x and x, or something like this, two binomials. So I believe this will be x minus 7, x plus 1. And then on the bottom, I have that 2x to the 4th. And this is a difference of two squares, which is x minus 7, x plus 7. From way back in Algebra 1, we should know that. Now, let's start canceling things that I can see that cancel. Now, right away, I notice that my x to the 7th go away. Or sorry, x to the 7th. Misspoke there. x minus 7 and x minus 7 go away. I can't cancel x plus 1 and x plus 7. I can't cancel those out. That's because they're just different terms. But over here, can't cancel the 3 over 2, but I can cancel the x's. I can cancel all 3 of those x to the cubes and just cancel out all but 1 of the x to the fourths. So what I'm left with after all that is the 3, that's gone, and x plus 1, all over 2x. Let's cancel it. We're going to write down everything that I didn't mark through, and x plus 7. Oops. Now, remember, the x to the fourth went away because I canceled out 3 of the x's, x cubed. I canceled out x cubed from the x to the fourth, so that leaves me with just 1x. Okay, and I can talk about that concept a little bit more tomorrow. But this is my final answer. Now, I have to list the domain. So what I have to worry about now is what makes the denominator 0. So right now, my denominator is 2x times x plus 7 equals 0. So what that tells me is either 2x equals 0 or x plus 7 equals 0. So x equals 0 or x equals negative 7. So my domain, and the way that we're actually going to write this, let me move what I just did down here. The way that your book's going to write this and the way that I want to write this, we're going to say for all x except x equals 0, and x equals negative 7. Okay? Now, there's one thing that's kind of weird that we have to check. What I'm going to do all the way back up here is test what makes this thing 0. Because there might be, because it's an even function, it might also be 7. So in my calculator, if you type in 2x to the 6th, 2x to the 6th, and minus 98x to the 4th into your calculator, what you will see is that it does cross the x-axis at 7. So what that tells me is you have to also list x equals 7, and I'll talk about that tomorrow. Remind me to talk about that tomorrow. Let's look at the next example here. Simplify each expression and show the domain for which the identity with the two expressions is valid. All right. So the first thing that I'm going to do is factor. Factor everything. So this top will factor into x plus 1 times x plus 1. The denominator, you can factor out an x, and you're left with x squared minus 2x minus 3. Now, I do believe that that denominator factors one more time. There's the numerator again. The denominator still has that x, but I think it's going to factor into x minus 3, x plus 1. That'll give me this binomial. Now, from this step, I'm going to get my domain. This is going to give me my domain right here. Before I even cancel anything out. Okay, because all of this down here is pretty easy to see what's going to make my denominator 0. Right here, x can't be 0. Right here, x can't be positive 3. Let me erase that and make that a little bit clearer. And right here, x can't be negative 1. So my domain will be all x's except for those 3 numbers. But yes, I can cancel some things out. I can come through and cancel out one of these x plus 1s. So my final answer here is actually going to be x plus 1 over x times x minus 3 for all x except the 3 that it can't be, except x equals 0, 3, and negative 1. Okay? Now the reason that when we look at the graph, and tomorrow we will look at a graph of what happens when we cancel these out. You know, these are going to be vertical asymptotes. Remember, what makes the denominator 0 is your vertical asymptotes. But what happens when it cancels is something different, and we're going to talk about that when I see you guys in class. Let's move on to example 3. Find the simplified form of each product and give the domain. Okay, so the simplified form of each product. Now, if you look at this part, it's kind of weird. And yes, I do know there are part B's to both of these, and we're going to also do those in class as a refresher for watching the video. So obviously, I'm going to rewrite this first one as, that's 4 minus 16 all over 9 minus x. Actually, I just went ahead and double checked something because that was really weird, the fact that it has a 2 there. It's supposed to be x squared. If it's not x squared in your book, this is supposed to be x squared. I don't know why they did that, but it's supposed to be x squared there. Let me rewrite that. Okay, I don't know why there's a 2 on mine, but if your book, if your student companion says 2 there, change it to an x. So it's going to be x squared minus 16 over 9 minus x times x squared plus x minus 90 all over x squared plus 14x plus 40. Now, remember when you multiply fractions, it's real nice. You just multiply straight across. So really what I could do is just distribute all of these or just write these into one fraction. Okay? And that's kind of what I'm going to do. But I'm also going to factor it at the same time. This one becomes x minus 4, x plus 4. Okay? This one will become x and x, and it'll become 9 and 10, and it'll be plus 10 minus 9. This one is x and x, and I need to make a 40, so it'll be 10 and 4, and they're both positive. So what I have here is x minus 4, I'm just going to write everything down straight across. X minus 4, x plus 4, x minus 9, x plus 10. That was my numerator since it's been factored and multiplied together. All over 9 minus x, x plus 10, x plus 4. Okay, so right here I can get my denominator. My denominator, I now know that x can't be 9 because 9 minus 9 is 0. It can't be negative 10 because that makes this parenthesis 0. And it can't be negative 4. Makes that parenthesis 0. So we're going to remove some of these, what we're going to call discontinuities. We're going to remove some of these zeros, some of these asymptotes by canceling. But what I notice right now is I have an x plus 4 and an x plus 4 that can go away. Let me do that differently. These two can go away. Okay. Also, the plus 10, x plus 10 and the x plus 10s can go away. So right now what I'm left with is x minus 4 times x minus 9 all over 9 minus x. These two look very similar, but they're not the same. I have a positive x, negative 9, and here I have a positive 9, negative x. So what your book's going to do here is rewrite this. It's going to factor out a negative from the bottom. And if I just randomly factor out, and that's really what we're doing here, it's just kind of a random thing, factoring out this negative 1, that leaves me with x minus 9. Take a negative out of x, you get positive x. Take a negative out of a positive 9, you get a negative 9. If you redistribute this, you get what you started with. And now I can cancel and be left with x minus 4 over -1, which is really just negative x minus 4. Okay, and our domain is right there. X does not equal 9, -10, or -4. So that was a product that canceled everything out. It's kind of weird that we were multiplying and ended up getting something smaller. Normally when you multiply, you get bigger. So that was kind of a strange problem. Okay, we'll do the next part B in class just to clarify that out. If you look at part B, it's longer. It's got 3 parts to it, but that's okay. So I'm going to actually pause the video here because it's getting longer, and we'll do the rest of these examples. We have 3 more examples here to do in class, so I can talk to you guys face to face and catch everybody up who is a slacker and didn't watch the video. So make sure you're taking that. There is obviously no problem set to go along with this one right now, but we will do that in class next time I see you guys. I hope you guys are doing well. This is Kishner out.